Last class we discussed sector, which I said is the region bounded by two radii and an arc. Today we'll be working on segment. That's what we'll be doing. There is no particular definition for a segment. It can be a region enclosed by the chord and an arc of a circle, like in this case. It can be a region like this shaded part is also a segment. You can have something like this shaded part is also a segment. So there is no particular definition for a segment. Now, since we don't have a particular definition for it, it demands you using your initiative. There are cases where you need to subtract some areas from another. Some cases you need to add. For example, this first diagram you have here, if I want the area of this shaded part, that means I have to consider my sector, these two radii and this arc. Then I'll remove the triangle from the sector. When you remove your triangle from this sector, you will have this shaded part, which is your segment. So if I want the area of this shaded part, the simple thing I'm going to do is to look for the area of this sector, look for the area of this triangle, then subtract, and you will get the area of this shaded part. Therefore, for the sector, its area is, as usual, theta by 3 times pi r squared. The angle is 56. Use 22/7 per pi. Your radius is 15. Remember to square. 15 squared is 225. And multiply your top numbers, you have this. Multiply the bottom numbers, you have this. Divide this. Area of the sector is 110 cm squared. For your triangle, when a triangle is not a right angle triangle, like in this case, we've discussed that before, you use this. Half the product of the two sides, sine the angle between them. So half 15 times 15, sine the angle between them. Write your sine 56 to 4 decimal places, as if you are using 4-figure table. Multiply, divide by 2, and you have the area of the triangle to be this. Therefore, the area of the shaded segment is area of the sector minus area of the triangle. Put in your values, and you have this. Since we were not told to approximate, give your work to 2 decimal places. That means I stop at 3. After decimal point, you start counting 1, 2. You take 1 from here, you add to this 3, and you have 16.74 cm squared. Now, when you consider this diagram, here is another one. We want the area of the shaded part. This one I'm tracing here is a square. The other one is a circle. Then you have this part, which is a sector. When you consider your square, remove your circle from it and add your sector. You will have exactly this shaded part. Now, to get the size of your square, when you check your diagram, from here to here is 7 cm, which is radius. Here to here is 7 cm, which will also be radius. Therefore, diameter is 7 cm, and that gives a side of your square. So the square is 14 cm by 14 cm. This is your circle with radius 7 cm. This is your sector. The angle is given. So look for the area of your circle, length times length, to give you this. Look for the area of the circle by r squared. You have to use 22/7 for pi. The answer will give you this. Look for the area of your sector, theta by 366 times pi r squared. Put in your values as we've been doing. 7 square is 49. Multiply the top numbers to have this, the bottom numbers to have this, and you have the area of the sector to be this. Then come and apply what we say here. Area of square minus area of circle plus area of sector will give you area of the shaded part. And that is what you have here. Area of the square minus area of the circle plus the area of the sector. That will give us the area of the shaded part. And that's what you do there. Also, I have another one I wanted to look at. Look at it. The first thing we have to do is to get the radius of the semicircle. Radius of the semicircle can be OZ or OY or OX or OW. Radius is always distance from the center of a circle to the circumference. For you to get your radius, remember they told us angle ACB, this angle is 130. That means this part is 65, this part is 65. When you divide 130 by 2, then join O to Y, you will have this triangle you have here. Your OY is the radius. Then this angle here, as I said earlier, will be 65, half of 130. This length is already given as 30 from the question OC. You use your trig ratio we discussed. This is our opposite where 65 faces. This is our hypotenuse, therefore we use sine. Sine 65 will give us opposite of hypotenuse, which is this. Sine 65 is this. Always give it to 4 decimal places. You cross multiply. 30 will multiply this, and R gives this, which you have to give your answer to 1 decimal place, and it becomes 27.2. 1 decimal place, after decimal point you can't. You stop at 1. You take 1 from 8 to join to 1, and you have 2. So the radius is 27.2 cm. The second question is to get the area of the shaded part. Now, you can follow many steps. I decided to use this approach. Let's consider this triangle OBC, where this angle is 65, this length is 30 cm. This will be a right angle, and we'll just look for length OB. That's what we have here. This is the opposite where 65 faces. This is our adjacent, and this hypotenuse. We have opposite diagonal. So you use tan 65 is OB over 30. Tan 65 is OB over 30. Tan 65 is this, which is this, plus multiply, and OB gives you this, which is this. Now, OB will be AO. OB will be AO from the diagram. They are equal. Therefore, AB will be OB plus AO. And that's what we have here. So that your length AB will be 128.67 cm. Then, if you want the shaded part, see what will help you. You see your triangle minus your semicircle. It will give you the shaded part. So we look for area of our triangle. This is a right angle triangle, so we use half base times height, which is half our AB times our height, and that will give us this. Semicircle, area of semicircle is half of that of a circle, half pi r squared. Pi is 22 over 7. Use this as your radius, and we'll have this. Therefore, the area of the shaded part is area of your triangle minus area of the semicircle. Put in your values. You have this. You have to give your answer to 1 decimal place. You stop at 3. and take 1 from it to join to this, and our final answer is 768.4 cm squared. Thank you.